All right, today we're going to do some more problem solving, and today we're just going to work on two-step problems. Those are the most challenging for us, and so the more practice we have, the better. We'll be using the read, draw, write process. So remember, read, R stands for read the problem and underline your knowns. D stands for draw a visual to represent the problem, and write stands for write a number sentence and a target sentence to show your answer. So let's read the problem first and underline our knowns. And what I would suggest is that you don't have to copy the problem over, but when I start to show my work, you do that same work on a separate piece of paper. That's what the boys and girls in school will be doing on a whiteboard. If you want to get a little whiteboard to work on too, that's fine. It makes it a little bit more engaging and something different than just writing on paper. So you can do that. And remember, please pause the video whenever you need time to catch up. Okay, I'll try to go slow. Mel picked 26 blueberries. I'm picturing Mel, and she just picked 26 blueberries. Lewis picked 37 more blueberries than Mel. So what do I know there? Lewis didn't pick 37 blueberries. He picked 37 more blueberries than Mel. A, how many berries did Lewis pick? And B, how many berries did they pick in all? So this is a two-step problem where they actually gave you the two questions that you have to find in order to get your final answer. Okay, so how many berries did Lewis pick? Well, he picked more than Mel. So when I've got one number and I know it's more than another number, or one number and I know it's smaller than another number, then that's comparing numbers. So when I compare numbers, I'm going to draw this, a tape diagram with two bars stacked. Okay, now one bar will represent the berries Lewis picked and one bar will represent the berries Mel picked. Well, Lewis picked more, so his will be the bigger bar. So I'm going to label the bigger bar with an L for Lewis. And then I'm going to label the smaller bar with an M for Mel. Okay, now I know that Lewis picked 37 more blueberries than Mel, and Mel picked 26. So let's put the 26 in here. That's pretty easy. I don't know how many Lewis picked though, because that's my question. How many berries did Lewis pick? So I'm going to put a question mark in there. But what I do know is that he picked 37 more blueberries than Mel. So where on my diagram is that 37? Well, it's how many more he picked than Mel. So it represents how much bigger his bar is than hers. So that's my 37. All right, now knowing that Mel picked 26 and knowing that Lewis picked 37 more, I can now write a number sentence to go with my picture. So my number sentence will be, and then I got to say to myself, what am I going to do? Am I going to add 26 and 37 to get this bigger number, or am I going to subtract? Well, he did pick more, so I'm going to take Mel's and I'm going to add that 37 to it to get what Lewis picked. Remember, this is your number sentence. It's written horizontally, just like a number sentence in ELA or reading would be. Now, I'm going to use the algorithm over here on the side to solve because that's hard for me to do mentally. So I add the ones, 6 ones plus 7 ones is 13 ones, which is 1 10 and 3 ones. And then I add my 10s, 2 10s, 3 10s, and 1 10 gives me 6 10s. So how many berries did Lewis pick? Now we need my target sentence. Yes, he picked 63 berries. And that makes sense because I know Mel picked 26 and he picked more, so he picked 63 berries. Now, a lot of times with a two-step problem, I probably should have done this in the beginning, we want to split our work area in two, and then we can have space to do both of our problems that we have to work on. How many berries did they pick in all? Now we're not comparing anymore. We are trying to find a total. We want what Lewis picked and we want what Mel picked and we want to add them together. So a good visual for that is what we call a number bond, where two parts make a whole. So it is part, part, whole. All right, and this whole is my question mark. I want to know how much they picked all together. I'm going to label my two parts, an M for Mel and an L for Lewis. And once again, I go back and I can look and see in the problem that Mel picked 26 berries. And then remember, I didn't know how many Lewis picked. That's what I found out in part 1 of my problem, or in step 1. So he picked 63. That's what I found out with my work from step 1. And now I know that if I want the total, I'm going to add those two parts together. So again, here's my number sentence, and I'm going to add 26 plus 63, and I will get 59. I was able to do that mentally because there was no regrouping. But again, you can always do your algorithm over on this side of your board. Actually, it's 89. Good thing I did that algorithm. Okay, 89. All right, and then finally I need my TS. How many berries did they pick in all? Yes, they picked 89 berries in all. Two-step problem where they broke out the two questions that you had to answer. Okay. Comparison, we used a stacked bar model. Part whole, we used a number bond. All right, we're going to go back and we're going to erase erase it all, and I'm going to slide my screen up. There's probably some way to undo all that. And we're going to go on to our second problem. Now this one is different because it has not broken out the two questions for me. Okay. Okay, problem 2. Kevin had 53 balloons. His cat popped 17 of them, that bad cat. His father gives him 18 more balloons. How many balloons does Kevin have now? So he had 53 balloons. I'm going to underline that. That's one of my knowns. Remember, this is the read, draw, write process. His cat popped 17 of them. So that means he has less now. And then his father gives him 18 more balloons. How many balloons does Kevin have now? Notice the difference between this problem and the first one. This one just has one question, but we're missing something in between, and that's what makes it a two-step problem. So let's split our work area in half. So split your paper in half, and we'll do step 1 first, okay? So Kevin had 53 balloons, and his cat popped 17 of them. Are you wondering anything right now? I'm wondering, after his cat popped those balloons, how many does he have left? It's always good to kind of think of the problem. What am I wondering right now? Okay, so if we think about that, he has a total number of balloons, his cat popped some, and he has some left. This is a classic part whole. So remember, for part whole, we can use a number bond where we have our two parts to make our whole. Okay, 53 balloons is what he started out with. That was his total. So we always put the total or the whole in the top. His cat popped 17 of them. So I'm going to put popped under here. I think it's really helpful, and I would suggest you always try to label your visuals with your tape diagrams or your number bonds, just so it keeps your work organized and helps you understand what you're doing. So let's put 17 in here. This is what they popped. And then this is what we don't know. This is what he has left after his cat pops them. Okay, we've read our problem, underlined our knowns, we've drawn our visual, and now we need a number sentence. Okay, so part whole, we're either going to add or subtract with part whole. When I look at this, I think, well, I could add 53 and 17, but that doesn't make any sense because he's going to have less balloons, not more balloons, after his cat pops them. So I think I need to subtract. In other words, whenever you have the whole in one part, you're going to subtract to find the other part. So 53 minus 17, I'm going to put my algorithm over here on the side. I can't take 7 ones from 3 ones, so I will regroup. 13 minus 7 is 6, 4 minus 1 is 3. And so he has 36 balloons left. And if you want, you can go back and write that in your circle or put it beside it. And finally, we need our TS. He has 36 balloons left. Okay. Now the second part, his father gives him 18 more balloons. All right, so now he has some and he gets more. Again, we're not comparing one number to another number, we're taking two parts and we're adding them. What he has and what his father gives him. And we'll get those two and we'll get a whole. So his father gives him 18 more. He has 36. That came from part 1 here. All right, and so this will be our total, and that is our unknown. We write a number sentence. If we have both parts in a part whole number bond, we add them to get the total. So 36 plus 18. Again, you can do your algorithm anywhere on the page that you have room. And that's 54. So now he has 54 balloons. So we would write PS, that's our target sentence. How many balloons does Kevin have now? He has 54 balloons now. Okay, and maybe if you're really good with mental math, and I didn't think of this, but I read it, maybe you could figure out that if his cat popped 17 and his dad gave him 18, then he has one more balloon than he started with. And if we look at that, and that's exactly what happened. He started with 53 and he ended up with 54. And that's because his father gave him one more balloon than his cat popped. All right, I hope you found that helpful. There's 2 examples of 2-step problems, and tomorrow you'll get some practice with a worksheet where you can do some independently. All righty, thank you.